Do you wish? So because we may get another 4 classes, we can solve at least 4 number of problems on clutches. So it's up to you. So if you include clutches now, the burden would be reduced for the final internal, that is third internal. So if you wanna exclude the clutches now, so it would be added to your third internals. And for this internals, worm gear would be again repeating worm gear plus V belts. Both the things has to be met. So internal portion. So I want you to choose up. The first option is worm gear plus the belts. Belts in the sense it includes flat and V. Okay. Second option is belts, which is flat plus V and clutches. And you have the portion for the clutches will be covered in the next 4 classes. So whatever is covered in the class, only that will be asked. So I want you to choose I want you to choose either of the options, option 1 or option 2 in the chat box. Make it fast. This is option 1 and this is option 2. Okay then. So if you, okay, most of you are going with option 2. Okay. Okay. Fine. Good. So if you are going with option number 2, then it clearly indicates that we should touch upon clutches. And for clutches, we would be having 4 classes starting from Monday, Tuesday, Thursday, and Wednesday. Okay, Thursday and Wednesday. So totally 4 classes would be there, and all the 4 classes you need to be attentive. Okay, so whatever is being covered in those 4 classes, the same would be coming for the second internal portion. Is that clear? Okay, so today what we'll be doing, we'll be solving one complete problem in the V-builds. We have totally 3 problems in the V-builds. All the other 2 are very much similar to the first one. And sorry for not having the class in the previous day because I was not feeling well totally. Today I'm a little bit better, so in a position to talk. So yes, today we'll be completing this particular problem, and I will just give a hint of problem number 2 and problem number 3 and give you the blueprint of those 2 problems, and you have to solve it for yourself. Okay, is that clear? So from Monday we will be starting with clutches. Is that fine? Okay. Okay, fine. So we were at the last few steps in the previous problem. We have completed all the steps, all the 10 steps. We are last step, in fact, 11th step is there to calculate the number of belts. I told you this particular thing is very, very important. So I guess in order to calculate the number of belts in a V belt, when it comes for a design-oriented problem, you have to use this particular equation. If it is a numerical thing, it's a different story. Whatever you have used n dash AV divided by 1000, that particular formula can be used if it is a numerical oriented problem. But if it is a design oriented problem, then you have to use this particular equation. So it says it is P into Ks, Kw into Kl and Ka, which is equal to P into Ks is nothing but Pd, Kw into Kl into Ka. And this particular equation is being taken from 14.14, page number 295. Okay. So please do check your data handbook for this particular equation. Page number how much? 295. Yes, here it is. Okay, so P into K is number of belts required. So if it is a design oriented problem, inevitably you have to use this particular formula. Is that clear? So if it is a numerical oriented problem, you have to use n dash AV divided by 1000. So in this, so few of the parameters need to be extracted. For example, Ks, we have already done this. So we have already calculated the design power. So no need of that particular thing, which is already done. So no need to worry much about it. KL is correction factor for length. We have to pick it from table number 14.20. And K is the correction factor for arc of contact, that you have to pick it from table number 14.21. It's very easy. You can just pick the values from there based upon the length and the arc of contact, whatever you have calculated in your previous steps. Okay. So please refer your data handbooks for this particular problem, which is this. And give me the values of KL and KA. KL. KL is correction factor for length, okay, which is taken from 14.20 from table 14.20. Next is KA. It is correction factor for arc of contact. Arc of contact, which is equal to, you have to give me the value, and which can be taken from table number 14.21. Any issue while picking up the value, please discuss with me. If you have any issue, please do discuss, then you can take the values. Okay. Please do discuss. Please go to the tables, all of you. I want you to see on what basis are you going to select the value of KL. What do you require? On what basis are you going to select the value of KA? So please do refer the tables 14.20 and 14.21. Any issues, if you are facing something new there, please do discuss. So that is very, very important. If you discuss, then you'll get it. KL is one value which is suggested by Nitish. He says that we have to go with the value of 1.16 for the value of KL. Everyone agrees on that? So on what basis did you select the value of 1.16? What were the constraints there? What were the columns or rows on which you decide upon 1.16, Nitish?
Nominal inside length.
So we require a nominal inside length, it seems, in order to pick a value. So do we have the nominal inside length? Do we have the nominal inside length for our case? So we have taken it from the previous steps. Okay, good. So what else we require? Only nominal inside length. Let me have a check. Can you give the page number, Nitesh?
323.
Okay. 323. So this is correction factor for length. Okay, so based on even the belt cross section, you have to decide, I guess, right? So what was our nominal length?
7569.
7569. Huh? Okay, so just checking that particular value, 7569. Oh, it goes, okay, 7569. I have found this value here. So what was our belt category? I guess column number 4 is C. We have selected upon C, I guess. So for C, it is 1.16. Good. 1.16. Everyone agrees on this value, 1.16. Shall we fix upon this? Everyone?
Yes, sir.
Good. Good. Next, we have to look for arc of contact. Correction factor for arc of contact. Please go to the table, immediate next table, 14.21. So this is the correction factor for arc of contact. So what is this? Can anyone just, by visually looking at it, can able to imagine an anti-FI, what we have to go with, whether we have to go with V to V or V to flat? Which one should we go? Whether to go with V to V or V to flat, what does it indicate actually? What is this? So we have two different columns. I have the arc of contact values here. I will match my particular value. Suppose if it is 162, I will pick a value. In order to pick a value, I have two different columns. I have to choose one. So one is V to V, the other is V to flat. So what is this? Can anyone have a guess on this? Yes. Anyone can guess what it is? No one is getting the idea for it? Sorry. 163 is the arc of contact. Okay. So, okay. Okay, so what is the value given? We have calculated arc of contact. How much did you get? 160, isn't it? 160.52. It's up to you, man. 160.52. I guess you have calculated in radians, I guess, isn't it? Convert into degrees. You'll get this value. Am I right? Is the value correct? 160.42 something. Okay. So if it is 160.42, either I can go at 160 or 163. It's up to you. Okay. If you want your element to be too costly, then you'll go with 163. You want to be less cost effective, you can go with 160. It's up to you, man. The values will not change much, I guess. It is 0.96 though, 0.95, 0.79, 0.8. So either of the ways you can go. It's up to you. Okay, you can go up for 163 or you can go for 160. But my question is, what is this? First, I have to decide this. No, what is V to V or V to flat? Based on that, I can pick a value. What is this? Anyone? Mohammed Saad?
Yes, sir.
So what do you think? What is this V to V or V to flat? Sudhanshu?
So type of pulley used.
Exactly. I guess we have solved a problem where a V-belt is used to drive. V-belt in the sense will be having a groove inside it like this, isn't it? V-belt in the sense will be having a groove inside it. Something like this. Okay. So in the sense it will be having a groove like this. Hope I am clear, right? So that is V-belt pulley. Flat belt pulley in the sense it would be a straight pulley, something like this without a groove. Getting my point?
Yes, sir.
So in this case, are we transferring a belt from a V-belt pulley to V-belt pulley, or we are transferring V-belt to flat belt pulley? In our case, in this particular problem case I'm talking about. I guess nothing has been specified. So generally what we will do, a pulley would, V-belt pulley would transfer to V-belt pulley, no? That is the general idea what we follow. Yes or no? In the rare cases, ಸ್ವಲ್ಪ ತಲೆ ಕೆಟ್ಟಿದ್ರೆ ಅವಾಗ ಮಾತ್ರ ನಾವು ವಿ ಬೆಲ್ಟ್ ದ ಫ್ಲಾಟ್ ಬೆಲ್ಟ್ ಕೊಡ್ತೇವೆ ಅಸಹ್ಯವಾಗಿ ಈ ತರ something. Hope you are getting what I am saying, isn't it? So unless and until unless and until he has specified that it is V belt to flat belt pulley, so which one would you prefer as a design engineer? Which one would you prefer? Will you go with V to V or V to
V-belt
flat?
to V-belt.
Isn't it? It's a common sense. Very good. So I'll go with V to V. So just write a sentence selecting V to V transmission and which one to select, whether we shall go for 163 or we shall go for 160. So which one? So this is fixed upon now. This one is confirmed. Now two values are there, 0.96 and 0.95. 163, that is 0.96, and if you go with 160, it is 0.95. Which one we shall go? We shall go for a common thing so that our values in our notes should be same. Which one we shall go? 0.96, 0.95. Look at the value. It is 160.42, just above 160. 0.96. Okay. What about others? 0.96. Considering safety. Okay, guys, fine. We can go with 0.96. So, so 0.96 we will consider it. Most of the guys have said that. Few are going with 0.95. So we'll go with uniformity. So please write the sentence selecting V to V transmission. Selecting V to V transmission. So you have got the value as 0.96. So I guess KL and KA are done. Now the only thing which is remaining is that value of KW. Please do listen here very carefully. So KW value can be calculated by two alternative methods. One, you can use the tables. Other, you can use the formula. Okay. I prefer always go with the formula method to calculate the value of KW, because when you go with the table, you have 5 different tables. I guess it is mentioned in the data handbook also, where we picked up this particular formula. What was the page number? I guess it is 295. So KW can be taken by table number 14.18. It is a 5 page table, one table for one belt. A belt has separate table, B belt has separate table. You can pick the value from that. But what happens, whenever you pick a value from a table, not only in this problem, in every parts of design I'm talking about, when you pick a value from a table, it would be an approximate value, not an exact. By chance, if you have a formula to be calculated for this particular parameter, so always go with the formula. Either you can use all this equation, 14.13, he says, see, in order to calculate KWF, so you have all these equations based on the belt category. So which category of belt do we have? Do we select it? C type. So pick this huge formula. Okay, pick that particular huge formula there. So which says, I would just write KW formula. So KW is equals to 2.01 V to the power of minus 0.09 minus 194.8 divided by DE minus 3.18 into 10 to the power of minus 4 V square into 0.7355 V. I guess you know the value of V. What is the value of V? It is 25.13. Correct? Is the value of V right? Yes, okay, fine. So, fine, B is done. The only thing which I am worried about is the value of D. So, how to calculate this D? Anything which is given in the data handbook regarding D? Anything given? 300. So, how did you get 300? Dhanush, that's correct. But how did you get 300? Can you explain it? Maximum value. Yes, it's simple, guys. I tell you, it's very, very simple. You can look here. D is nothing but equivalent pitch diameter, which is given here, which says it is D, that is equals to D cross KD. I would just take that. DE is equal to what? It is D cross KD. So I know the value of D, which is 400. But what about KD? KD I can get it from table number 14.15, which is in the page number 314. Okay, so what is the value of KD? Anyone? Value of KD, small diameter factor, he says. Anyone could help me with the value, or else I have to scroll. He says it's in page number 314. So here it is, small diameter factor KD. So based on the speed ratio, you have to decide. So what is our speed ratio here? What is our speed ratio? You have to always take the revised one. It is 3.125. Not 3.125. Have revised after standardizing the diameters. No, that particular value you have to take 3.125. Anyhow, so for 2.9 and over, it is 1.14. So I would pick that particular value. So it is 1.14. If I multiply this, it would be around 456 mm. Okay, fine. You have got 4, 5, 6 mm, but come back to this particular table. So do not substitute the value of DE as 4, 5, 6. Just have a check here. Again, I have to scroll back. Okay. So here he says, look at this. He says the maximum value of D in the formula should be 300 for C-belt drive. But how much you have got? You have got 456. But he says whatever you substitute in this formula, the maximum value should be how much? It should be 300. So what we have to take, whether to take 300 or whether to take 456. The maximum value you can substitute in this particular formula is 300, he says. Apart from that, you should not cross. So selecting that particular value. So before that, you just write a sentence. Okay. Fine. Now, according to data handbook, maximum value of D should be how much? 300 for C belt type. Correct. Therefore, selecting D is equal to 300 mm. Is that clear what I have done until now? Is that clear? Sorry. Okay, fine. So I guess you have known what the value of KW. Now KW has to be calculated. Please substitute the value of all the things. So it is 2.01 cross. Just substitute and give me the value, guys. I will just write a sentence here. Substituting get KW value as how much? Can you give me the value of KW? Okay, 12.08. Now, finally, calculate the number of threads. I guess you don't have any constraints there. It was 18 divided by 12.08 cross 1.16 cross 0.96 is the value what you have selected. So, what is the number of pets? 1.33. Then what is the number of belts here? So there ends your problem. So if you write 2 at the end of your question or your answer sheet in your examination, you'll get full marks. Simple. Okay, and that is all the need. Of course, all the steps will be having the marks, but primarily, while evaluating for the belts, he will look for number of belts. Number of belts is the most important. Okay. Any doubts in the problem? At lastly, you can specify the belt. That is step number 12, they call it as. If you want, you can do it. Otherwise, nothing marks will be deducted for it. Generally, this thing, industrial segment, at last they will specify the belt like this in a paper. Okay. Belt specification you have to mention. How you have to mention is the belt type against the inside line. So for example, now it is C belt. So we just write C. Inside line as 7569. And even I would draw the dimensions of this V belt. Okay, like what is this? What is this? And what is this? Okay, there ends your problem. And quoting cross 2 at the last, indicating the number of belts which is required. So this is how you specify a belt. That means you have designed something. Now you want to give the orders for an diploma holder. You will write such kind of statements like this. C type of belt, 7569 is inside length. You require 2 belts for your operation and specify all the dimensions and give it in your paper. He will perform the remaining job. Hope I am clear. What is specification? What we are doing like this? Why you are doing like this? All. Am I clear about this? That's it. So there ends your design. Okay. Any doubts in this entire designing of V-belts? Can please discuss. Any doubts if you have? Okay. Okay. Only one response. What about others? Do we have doubts? Good. So please do try this problem. I have given with all the values required, but we have to put it in a proper format. As I have solved the first problem detailedly, in the examination also, you have to solve in detail like this. So what I have done is I have just given the blueprint like this. Last you'll get N5. Okay, so this is a blueprint with the final values. Solve for the current problem in the same way what I have solved. You can check the values from here. Okay, similarly 2 problems. Same thing I have done, indicating the number of belts at the last. Okay, will you solve these 2 problems? Anyhow, values will be there. If you have any doubt, you can contact me anytime. Will you solve this? Okay. Okay, so now we shall end the class here. What you have to do is I will just raise a classwork for today's session. So these 2 problems has to be solved. As I have solved the first problem, if any doubts if you get, please do contact me. Okay, you have to solve in the same way what I have done in the first problem. And you can particularly submit